Hi, this is Mr. Roix, and I'm going to take you through the homework problems that you'll find on the Google Classroom web page, the 5 problems there. And so I'm going to show you how to do the dimensional analysis. These problems are a little bit long in terms of the number of conversions you have to do, although they really aren't any harder than any other dimensional analysis conversions. So the first one asks for the mass of a 55-gallon drum. And we are given the conversion factor that includes the density in grams per centimeter cube. So how we solve for this is we start with the 55 gallons, right? And since the density is given to us in grams per centimeter cubed, we want to convert our volume of gallons into centimeters cubed. So the first several steps here is converting from gallons to centimeters cubed. So we can do this by saying that there are 4 quarts, sorry, that's a Q, in 1 gallon, and there are 1.06 quarts in 1 liter, and then there are, in 1 liter there are 1,000 milliliters, and then in 1 milliliter there is 1 cubic centimeter. So now we have it to cubic centimeters. And if we want to solve for mass, what we can do is the density is given to us as 1.5942. We can just break this value down here and separate out into grams and centimeters cubed and then solve. So basically what we're saying is if we have 1 centimeter cubed based on the density, the mass of that 1 centimeter cube would be 1.5942, and that would be in grams. And so if we want to solve for pounds, the last step is we need to convert to pounds from grams. So there are 454 pounds in 1 gram. And so if you look at our labels, gallon cancels gallon, quarts cancel quarts, liters cancel liters, milliliters cancel milliliters, centimeters cubed cancel centimeters cubed, grams, and I'm sorry I wrote these backwards, but this is supposed to be grams, and this should be pounds, sorry, got those mixed, right? And right away I knew that I made that mistake because grams can't cancel pounds, but grams can cancel grams. Now it's just a matter of doing the math, and if we do the math out, and appropriate number of significant figures based on the value of 55 gallons would be 2 significant figures. So I come up with a rounded or significant figure mass of 730 pounds. So that's how you do a problem like that. Again, it takes a few steps. There are some steps as we go along. You know, if you don't need to do maybe this step here, we could just convert, but not bad to practice with that. All right, next question. The next questions gave us basically 3 different measurements of aluminum, and it asked which got the greatest volume. And it gave us the density of aluminum to be 2.70. So density of aluminum is 2.70 grams per centimeter cubed. So if we take the first value they give us, they said if we have 1.4, I hope that's 1.4 pounds of aluminum, what would be the volume of that? So we want to convert from pounds to grams because our density is in grams. So we could say 1 pound is 454 grams. Now we have it in grams. Now we're going to use that density. And we're going to say that if we have 1 centimeter cubed, it is 2.70 grams. Okay, and now if we solve for this, again, pounds cancel pounds, grams cancel grams, and we're left with an answer in centimeter cubed. With 2 significant figures based on our original measurement here, we end up with 1.0 or not 1 point, 170 centimeters cubed. So that's our rounded to the correct number of significant figures. Second value, they had, if we have 0.5 kilograms, so 0.50, sorry, kilograms. And again, convert kilograms to grams. Now we can again use this same factor that we did here. In 2.70 grams, you're going to have a volume of 1 centimeter cubed. And again, kilograms cancel kilograms, grams cancel grams. Do the math, and we get an answer of 190 centimeters cubed. That is again based on 2 sig figs from this value right there. And then the last one, they just give us a volume, and they say if you have 0.050 liters, okay, we're going to convert liters to milliliters. So 1 liter is 1,000 milliliters. Conversion to centimeters cubed is just 1 milliliter is 1 centimeter cubed. And again, labels cancel. Liters cancel liters, milliliters cancel milliliters. And our answer comes out to be 50 centimeters cubed. So the one with the greatest volume would be a half a kilogram. Be right here. All right. So that's how you do number 2. Number 3. And again, if any point I'm going too fast for you, just go back, start the video over, back it up a little bit, and then take a look at it. So problem number 3. Okay, so problem number 3 asks if I have 100 pounds of sugar and it occupies 1.008 feet, what is the density in grams per centimeter cubed? So again, we start with our known. Since we're given a mass, we start with the mass on top, right? Because density is mass per volume. So there's our mass. Our volume, starting volume, is 1.008 feet cubed. Okay. First step is our end answer needs to be in grams per centimeter cubed. So let's get the mass in grams. So we say 1 pound is 454 grams. Okay, now we're not worried about the mass label at all. We're just going to worry about the volume measurement. We need to get it in centimeters cubed from feet cubed. So we have a couple of steps here. Right, if the label is in the bottom and we want to get rid of it, we're going to put the same label in the top. So we put feet on top. Inches is what we'll convert to first. And a reminder that this is the original value is in cubic feet, and so we need to cube this value here. That means we also need to cube this value. So we have 12 cubed down there. Then next step is we need to get it into centimeters cubed. So inches goes up here, and in 1 inch there are 2.54 centimeters. Now reminder again that the inches are cubed, so we also want to cube this top value, and in doing so we're also going to cube the 2.54 centimeters. Now we do all the math with this. If we do it properly, we end up with a density of 0.8676 grams per centimeter cube. So that is our density of 100 pounds of sugar in 1.008 feet. And I'm going to finish up the last 2 problems on a second video that I'll post.